Hey everybody, welcome to this little video about gear ratios. We're actually in my garage at my house right now, and before us is a bike in construction. This is an old Specialized stump jumper from, I'm going to guess, the late 80s, early 90s. It's my buddy Brian's. He's asked me to help him build what's known as a single speed mountain bike. A single speed mountain bike is a mountain bike that has one gear in the front and one gear in the back, and they're combined with a chain. And the idea is when you spin that front, here, let's get a little closer so you can see it better. When you spin that front gear, the back gear rotates as well. So here we go. I'll give you a quick, this is definitely in construction and we need a lot of chain tensioning and things like that, but you get the basic principle. So you spin the front gear and the back gear turns. And on some bikes, you spin the back gear and the front gear turns as well, but I'm not building that kind because I like my buddy Brian and I don't want his knees to explode. So we're gonna build him a single speed mountain bike, and I figured this is the perfect opportunity to actually explain to y'all about gear ratios, which is what your homework is about. It's about how gear ratios work. Now this is how gear ratios work on a mountain bike. It's how gear ratios work on a motorcycle. It's how gear ratios work on a car. I mean, anything that has a transmission of some kind. And when transmission just meaning a gear connected to at least one other gear is going to have a gear ratio at work, at least one gear ratio, if not more. So today what we're going to do is we're going to analyze the gear ratios on this Specialized stump jumper that I'm building for my buddy Brian. So what I'm going to do is I'm going to get this thing close so that we can see the back gear really well. Sorry about the slightly ghetto nature of this video, but that's okay. I like that. It makes me happy. All right. So what we're going to do is, actually, I want to back that up a little tiny bit. If any administrator at COCC is watching, I could really use a production assistant for this kind of stuff. So what we're going to do is I want you to actually, I don't know if you can see it or not. I can see it here, but right there on the gear, there's a little letter QR. Let me see if I can get close enough so you can see it. Right there, QR. I don't know if you can see it. Right there, QR. And those are little stamps. There's all kinds of stamped numbers on these gears. The reason I'm going to focus on that is that gives us a mark that we can look at. So when I spin the front gear around, we can see when that QR shows back. There it is right there. So when that thing spins back around, we can keep track of how many times it goes around. Hopefully that makes sense. So I want to make it so you can see both gears turning. I'd love for you to also be able to see the QR. I'm not sure if we can accomplish all of that with what we've got here. Let me see if I can adjust the light. If I can adjust the light so you can see both. I think we might be able to pull this off. Okay, this might actually do it. You can kind of see, yep, you can see the QR right there. And then you can also see the front crankset over here. So I want you to take a quick look over here. I know it's out of focus right now. I'll spin it a little bit. That crank is oriented in such a way that it is parallel with this down tube right here. What I'm going to do is I'm going to spin this crank one time around so that it comes back to the same position. Okay, so one rotation, if that makes sense. One rotation around. Okay? Okay. And then what I'm going to do back here is I want us all to watch this gear while I'm turning that one once. And I want to count how many times this QR repeats itself up to the top. Okay, here we go. So right now, QR's at the top. This crank over here, which is now out of the camera view, is parallel with the down tube. Here we go. I'm going to start spinning it. I'm going to hold it with my left hand too so it doesn't go too fast. Okay. Watch for that QR. All right, it's right there. See, now it's at the top again. So that back gear has gone around one time, but I'm still going on the front. Front's still turning. Okay, here we go. And the front has returned parallel. I don't know if you can see that. Let me spin the camera so you can see it. The front has returned parallel. There it is right there. And the QR back here has gone twice. So let's think about what we just saw. This gear back here turned twice while the gear up here turned once. Now some of you might be saying, wait, the gear didn't turn once, the crank turned once. But remember, the crank is bolted to the gear. So if one turns, the other one has to turn. Okay? So this one back here turned 2 times. This one turned 1 time. And that's what I want you to focus on this entire homework. That's how I describe gear ratios. I describe them in terms of the number of revolutions the back one makes divided by the number of revolutions the front one makes. So if you actually pull this bike apart, which I don't want you to do right now, and you could see it. I don't know if you could see it as it went by. Right there's a little tiny, let's get closer. Pull the camera out of this thing for a sec. Here we go. Right. Let's get it in focus. Can you see it? Oh, shoot, I can't see it anymore. Oh, there it is. Right there. See how it says 16T? That's 16 teeth. This gear has 16 teeth. Now let's come over here. I'll throw some light on this gear. This one's going to be a little bit harder to see because I think it's on the back side. Let me rotate this puppy around so the light's in the right place. Okay. Let's see if we can find. I think I see it. I do. Come on down here, Mr. Light. All right. It's upside down, but right there. I don't know if you can see that number. It says 32. This puppy has 32 teeth. This puppy back here has 16. Now I want you to think about that. If the chain is binding them together, that means every time a tooth back here is engaged, a tooth back here is engaged. This one's got 32. This one's got 16. Clearly the bike is trying to fight. This one would have to turn twice as often as this one turns to keep the 32, because 16 times 2 is 32. Hopefully that makes sense. But that's what this whole homework is about, is making peace with that very idea of gear ratio. So what we're going to do is we're going to analyze all the bikes in this garage. We're going to analyze my single speed, which is right there, my old 2000 Kona Cinder Cone. We're going to analyze Jen's 1963 Schwinn Fleet, my favorite bike in the garage because it has the most class. We're going to analyze my Trek Madone road bike, which is the one I ride out to my Prineville, Redmond, and Madras campuses. We're going to analyze my fat bike, which is this guy right here. We might analyze my cruiser. That's my goofy little specialized Rockhopper cruiser. We'll see if we get to that one. And we're also going to analyze my commuter bike, which is the one that's over in the other garage. But right now, all 3 cats are in that garage, and if I open the door, they'll all escape. So we're going to stick with at least a few bikes until you get the idea, and that's what the homework's all about. All right, so let's do it.